Welcome. This is going to be the last talk for today. This is August 2023 TRiRODS, and Ajay was with us for the summer. He's going to talk about his work with the S3 transfer with automated ingest. So here you go. Take it away.
Hi, I'm Ajay Krishnamurthy, and I was an intern at iRODS this summer, and I was working on adding S3 transfer capability to the iRODS Automated Ingest. First, I'll just give a bit of an introduction about myself. So I'm a rising junior at Duke studying computer science and statistics. In my free time, I like playing basketball and football and watching them too. And I started playing chess recently. So if anyone wants to play me in any of those, just contact. All right, so now I'll go into background about the project that I was working on. So the automated ingest is a capability of iRODS that's built in Python. And essentially it aims to simplify the process of ingesting large amounts of data into iRODS. And so there's two main use cases, one of which is called the file system scanner. So let's say you have some existing file system that you want to have registered into iRODS or to put into iRODS. The automated ingest can do that for you automatically and efficiently, and can add things like custom metadata to the files in your file system. The other use case is called the landing zone. So let's say you have some data that's coming from a sensor and it's being written to a file in some landing zone. The automated ingest can recognize that there's been changes to that file and automatically copy that into iRODS. So next, I'm going to talk about a use case, like a real world example of how iRODS and the ingest can be useful. So let's say we have a research project involving a team of scientists and researchers from different institutions around the world. And this project generates a massive amount of data every day. The data might come from different sensors and simulations. So some of the challenges with dealing with a project of this size are that we are data management and data collection. So the data might be from the sensors might be stored in on-premises data centers, or they might be stored in the cloud in Amazon S3 buckets. And so integrating these different data sources to make it easy for your researchers to do their analysis is a challenging task. And then another thing is with data collaboration and data sharing. So you want your researchers to be able to easily access all the data that you want and have secure access and to give certain researchers different permissions, and that's challenging. And so that's where iRODS and the automated ingest can come to the rescue. So with iRODS being able to support S3 resources, you can seamlessly integrate the files that you have in your local file systems and the files that you're keeping in the cloud. And with the ingest, now you can set up your system so that as soon as files hit your S3 buckets, you can have them ingested into iRODS, put them into iRODS, have them tracked if you want to register them, and add custom metadata. So this makes it much easier for your research team to work efficiently. And another benefit of this is that with the data virtualization that iRODS provides, everything for the researchers seems like it's all in the same place. They don't have to worry about where to access some data, who they need to ask to get access to it. It's all easy for them. So the benefits of this are that now your research team can work much more efficiently and everything is much more streamlined. So with all that said, that's all great if everything works. But the issue is that iRODS, the automated ingest, only supported registering data from S3, but not actually transferring data from S3 into iRODS. So that's essentially what I was working on this summer. And the operation itself was called put. So that's what I have is putting is not supported in S3. Okay, so to address this problem, the first approach that we took was called the single stream approach. So we have some S3 bucket with our S3 objects. And what we did was we were using the Minio Python API to fetch data from that S3 object. And we're essentially just streaming through it in chunks and writing it to our iRODS destination data object. And so this solved the problem that the put was not supported from the ingest because originally the put was expecting all files to come from the local file system. But of course, S3 files are not on your local file system. And so this solves that problem and makes it so you don't get this file not found error when you try to run a put operation. But the only issue with this is that if we think back to our use case with our large project, we might have thousands of files, millions of files that are all pretty large. And so doing this single stream approach for all those files will take a lot of time, and that kind of eliminates the benefits that using iRODS and the ingest will provide. So this naturally led to the second approach, which is the multi-read and write approach. So it works in a similar way to the single stream approach, but now instead of doing it just chunk by chunk, we split it up into n threads, and each thread gets an offset and a partial object chunk, which is essentially a part of the S3 object that's split into equal sizes for each of the threads. So each thread reads through it in chunks and writes it into our iRODS destination data object at the correct offset. So we still get our correct copy of the file. And so now I'm going to show a demo of that working and also what it was like before I added my changes. Okay, so first I'm just creating a file called demo file, which is just a file with a size of 1 gig. So now I'm just going to copy it to my S3 bucket, which is being hosted on my locally running Vimeo server. And I'm just disabling multi-part for simplicity, and I'll show something later in the logs that will match that. So I've copied the file, and now I'm just switching to the code before there was S3 support. So now we should expect to see this file not found error that I was mentioning. So now I'm going to start the celery workers. So the celery workers are essentially what actually runs the tasks to copy the files. So now that they're running, I can actually run the ingest job itself. So first, I'll just do an ILS to show that there's no collections right now in my iRODS instance. And then I can actually run the job now. So this is how I run the job. So there's a bunch of options. The most important ones are the event handler I'm using is put.py. So it's just doing the put operation. And then there's some configuration options for my S3 bucket. And then you can see at the end, there's this /demo, which is the S3 bucket, the name of the S3 bucket, and then the name of the target collection, which is file not found. So we should expect to see the demo file in our file not found collection if everything works. But if I run it, you'll see that in the celery logs at the bottom that we get this file not found error, no such file or directory demo file, which is what I mentioned earlier with the Python iRODS client, but not expecting files to come from an S3, but rather to be local. So this is what it was like before I came this summer. And so if we take a look at the ILS of the file not found collection, you can see there is no demo file there. So we know it didn't work. So now I'm going to switch to the code after I implemented the single stream solution. So I just need to restart the celery workers for them to have that new code. And then I can run the job again. So essentially everything will be the same except the target collection. Now I'll call single stream just so that it's clear there's a difference. And so if I run the job now in the celery logs, you can see that there is no file not found error. And if you take a look here at this, you can see my cursor. We have this in the logs, this event uploading objects with the file name from S3. So we can see that it's working, and it's taking some time. If you look at the top, you can see the elapsed time. And so it's took around 9 seconds to copy the file into iRODS, which is not very fast for a gig file. And then if I do an ILS on the collection, you can see that this demo file is there. It has a size of 1 gig and it's being stored in the vault. So it worked properly, but as I said, it's a little bit slow. So that's what the multi-threaded solution is for. So I'm just going to switch to the main code, which has the multi-threaded support. So first I'll restart the salary workers again, and then we can run the job again. So just starting the salary workers up. Okay, so I'll run the job again, but this time the target collection will be called multi for the multi-thread solution. And again, we can see that it's working. And this time, if we look in the logs, you can see there's this task, iRODS S3 upload file, and the event is a parallel put, so it properly recognized to do it in parallel, which is what we want. And then now it's finished. So if you look at the top, you can see the elapsed time was 3 seconds, so much faster than the single stream solution. And you can imagine if we have a ton of files that would only make things better. So if we do again an ILS on our target collection, you can see that there's the 1 gig file there, demo file. So we know it copied it correctly. Okay, so the next thing that I did after implementing the multi-threaded solution was I wanted to quantify the performance improvement from the single stream solution to the multi-thread solution. So I created a test script to do that. So just some specifications about how I was running it. I was using a RHEL 9 virtual machine with 32 gigs of RAM and 8 cores. And the S3 bucket, as I mentioned earlier, is being hosted on a locally running Minio server. And I'm just doing the put operation again, since that we want to copy. So my independent variables were the number of threads. So I did the streaming and then 2, 3, 4, and 8 threads. And then the file sizes, I chose a pretty wide variety of file sizes, some smaller files and some larger files, to show that the streaming solution still has some value for smaller files, but for the larger files, we're going to want to use the multi-threaded solution. And then for the network latency, since my Minio S3 bucket is on my local virtual machine, I wanted to add some network delay to mimic a more realistic environment. So that's what I'm doing there. And then the number of files was either 1 or 15 files. And then the runs per config is how many times I ran each combination of the threads, file sizes, network latency, and number of files. And I was just measuring the execution time of each run. And I just took the median of those 5 runs. And there's a link to the repository where you can see the test scripts and data. So from the performance testing, we observed that the multi-threaded read achieved over 6 times speed up over the single stream, right, for a 5 gig file. So it's good to see that it actually did speed things up. And so this is a graph of the run times for the ingest for a 10 megabyte file. It's a little hard to see, but the streaming solution for the 10 megabyte file was the fastest. And as we increase the number of threads, the execution time increased. So this demonstrates that there's still some merit for this streaming solution. And on the x-axis, sorry, there's the network delay. So it's either 0, 50, or 100 milliseconds. And then the y-axis is just the runtime. So for the smaller files, as I mentioned, the streaming solution outperformed the threaded solutions, probably because of the overhead that came with using more threads. But as we get to the larger files, like 500 megabytes, the threaded solution started to outperform the streaming solution. So in this, the streaming solution is the slowest time, and the 2, 3, and 4 threads all perform significantly better. And as we increase the file sizes, the pattern becomes more obvious. So on the top, you can see the time it took for the streaming solution, over 10 seconds for all of the network delays for the streaming solution, but under 10 seconds for 2, 3, and 4 threads, which is good to see. And then if we extend it to 5 gigs, you can see the difference is just continuing to grow. And for no network delay, it took around 45 seconds for the streaming solution, but for any of the threaded solutions, it took under 10 seconds. So if you can imagine, if we have a ton of files that are this size, it'll save a ton of time, which is good. With all that said, there's still a lot of work left to do for the ingest. And so some of that includes refactoring the scanner in sync iRODS. So the scanner is essentially an object that is used to walk through the file system or the S3 bucket. And so when the multi-threaded solution was implemented, a lot of the upload functionality was moved from the sync iRODS file to the scanner to avoid having to recheck if a file is from S3 or local. But in the process of that, there was some tangled dependencies between that file, and that sync iRODS.py file may not actually be needed. So work could be done to simplify how that works. Then another thing is, if you saw in the demo when I did an ILS on the collection, so for the single stream collection, there was a checksum associated with the demo file, but for the multi collection, there was not. That's because for the multi-threaded approach, there is no checksum being calculated currently, but just checking that the number of bytes written is the same as the file size. That's because it's a little more complicated to do calculate a checksum when you're reading and writing in different orders. And then the last thing is to develop a way to sync the negative space. This is a more general thing for the ingest. So right now, the ingest is able to recognize when a new file comes into your local file system or something, but it's not able to recognize when a file goes away. So that could be something that could be useful for people that could be added. So just to recap my summer, I learned a ton. I learned about iRODS, as you can assume, which is not surprising since I was doing a lot with iRODS. And I really liked to fiddle around with iRODS, and it was a good experience. And then I learned a lot about Python, especially the more multi-processing and multi-threaded things, which was good since I had never done it in Python. And so it's something that I can keep in my toolbox, I guess. And then I learned a lot about GitHub and Git. I had a lot of questions for Alan, so I appreciate him always being there to answer those. And then the more ingest related things were the S3, Redis, and Celery, just some of the tools that the ingest uses. And then I learned a lot more Linux and Vim, I guess. I know Sean mentioned that because I was working in a virtual machine the whole summer, so get used to that. And then some more general skills. I learned how to be a good collaborator and also how to ask questions. So working with the iRODS team was really helpful. They're a bunch of really smart people, so there's so much I have to learn. So asking them questions definitely made things easier. And then I learned how to debug and problem solving. Definitely improved those skills over the summer. And then speaking a lot with Terrell and Alan about the best design and coding practices, like when I would make my commits and things. And then I learned how to be more patient. So I thought it would be really easy from the beginning to just start contributing and understanding everything, but it definitely takes some time, especially when you're adjusting to a new team and stuff. So I think that's an important lesson that I'll take for the future. And then I just wanted to thank Terrell, Corey, and Alan. They helped me a lot this summer. And then everyone else in the iRODS team, Justin, Dan, Marcus, you guys all were there when I had questions, so I appreciate that. So yeah, are there any questions?
I have questions.
Oh, yes.
Okay. So with first of all, good job this summer. Yay. Secondly, with the checksum problem, I was wondering, is that worked around if you do the checksum kind of posthumously as part of the post PEP on the client side?
Yeah, that could be done. The only thing is that you might lose some of the performance improvements, I guess, that
Sure.
you from the multi-threaded, right? But
I,
yeah.
I was also wondering if we had considered leveraging the finalize API as a way of calculating that checksum. Does that make sense?
I did not look much into the finalized API, so I don't know for sure, but I'll trust your word on it. So
Okay,
Yeah, it's gonna be a question of whether they want to pay the penalty live or if it's okay to calculate it later. So,
sure. Mhm.
yeah, we'll test and see if we can do it in the post.
So, sorry, if other people have questions. Does that mean the checksum is calculated always on the smaller files?
it's so I guess the thing is for the smaller files, if they're under 32 megabytes, that's when they're run with the single stream approach.
Mhm.
But for larger than that, it's the multi-threaded approach. So for the single stream, I'm pretty sure there is a checksum calculated.
It might be in our example. He just used the example put file. So
Yeah.
Okay, I was like, I feel like that's something you can configure.
I think
So,
it is. I think
Okay.
it's just on by default in that example.
all right, okay, that's fine. And my last comment was something I was thinking about during your presentation, which was have we ever talked about pointing this at the new S3 client
I don't think
to
so.
act as an iRODS scanner?
We talked about it, but we ran out of time.
Okay, I couldn't remember if we had talked about that or not, but I think that would be really interesting to see in the coming
Yeah,
months.
I think once all that works, we're gonna plug all these, we're gonna point all of them in all of them and probably be very sad the first time we do that.
But yeah, this is really cool. Thanks.
Yeah, so I got a question. Well, maybe two. So I'm assuming this is your first time working. Is this the first time you've ever worked on like a open source project with
Yeah.
a team of people?
Yeah, so that's another thing that I should have probably included in my what I learned, but I never had like contributed to like such a large code base and worked with like another team of developers. So that's something that I'll definitely be able to take on. It's like in the future, if I ever want to contribute to an open source project, I know like how to do that, how to start contributing. Which before was like a daunting task. I was like, I don't even know where to start, but now I can already tell like just when I'm doing like some projects on my own, like if I'm using some API, I can be like, if there's something that I wish could be included, I know how to start at least trying to add that to an open source project.
And I guess my second question is, so this is your first time dealing with writing multi-threaded code or writing software that deals with multiple threads, right?
Or just in Python.
Just in Python, in one of my classes, I did some multi-threaded work in C, but never with Python. And I was a little scared of the global interpreter lock, so I wasn't sure how feasible it would be. But I think for IO related tasks,
Yep.
it actually can work. So I'm glad I was able to figure that out.
Did you find anything surprising about dealing with threads in C versus Python threads?
I don't know. I feel like the threading in C maybe was a little simpler what I was working with, so it felt easier to do it in C for me. But it might just be because I wasn't working with as complicated of a project. But Python has like some useful libraries like the current futures thing, so that's helpful. And I was able to use a lot from the Python iRODS client, so that was helpful too.
Right. And my last comment is, once you're comfortable with threads, like maybe take a look at coroutines if you haven't looked at them.
Okay, I haven't. I'll take a look at that.
Got a comment from Alan, multi-threaded transfer in the context of a concurrent distributed workload manager. Yeah, probably a little trickier than what you did in class. Yeah, you picked it up pretty quick. I didn't know if you were gonna have time to do the multi-part, but you did it in 3 to 4 days, I think. It was pretty quick.
Yeah, no, Dan helped me a lot. He explained everything that was happening with it in the Python iRODS client. So,
Have we run a checksum against the multi-part to make sure it is actually?
yeah, I've
okay.
checked.
Okay. It is right.
Yeah, yeah. No, I was worried that the order of them, but it worked.
And we've definitely had experience writing zero-link files and the checksum always matches, and then you're
Yeah.
like, wait a minute.
No, I didn't do any zero.
Very good. Thank you. Anybody else? Can we clap?
All right, let's clap.